All right, let's dive into the world of ethical hacking. We're going to talk about a tool that is an absolute beast for testing password strength. It's called Hashcat. But we're actually going to kick things off with a super common problem, a real showstopper that trips up almost everyone when they're just getting started.
So picture this. You've got everything set up, you're all ready to run your security audit. You hit that enter key, and boom, you get this. No device found. It is one of the most common and honestly one of the most frustrating roadblocks you can hit. So what on earth is going on here?
Okay, so let's get into it. Here's what we're going to do in this explainer. First, yeah, we're going to solve this specific error. But way more importantly, we are going to uncover why the solution to this one little problem has completely changed the game for cybersecurity, for both the good guys and the bad guys. So that error message, what is it really trying to tell you? Well, it's saying that Hashcat, this powerful tool, can't see the single most powerful piece of hardware in your machine for this job, your graphics processing unit, your GPU. Right now, it's probably only seeing your computer's main brain, the CPU. So why does this even happen? Well, think of it like this. Hashcat needs a special set of instructions, we call them drivers and APIs, to talk to your hardware. It's like a translator. And if you don't have the right translator, like NVIDIA's CUDA toolkit, your super powerful GPU is just sitting there, completely invisible to the program. It knows there's horsepower in the box, but it has no idea how to talk to it. Now, the good news is, making your GPU visible to Hashcat, it's actually pretty straightforward. It just takes installing a couple of key pieces of software to bridge that communication gap. So let's just walk right through it. It really just boils down to these 3 steps. First, you're going to install the CUDA toolkit. That's what lets programs speak the GPU's native language. Second, you make sure you have the latest NVIDIA drivers installed. That's the direct phone line to the hardware itself. And then finally, you run a super simple command to check if Hashcat now sees your GPU listed as a device. And that's it. Simple as that. And this brings us to the real heart of our explainer. Okay, we fixed the technical problem, great. But why did we even do it? Why is using a GPU for password cracking so important that we'd bother with any of this? Well, the answer is all about how a GPU thinks. You see, the magic of the GPU, the secret sauce, it all comes down to a huge difference in how it processes information compared to a CPU. It's all about working in parallel versus working in serial. And this analogy just nails it. Your CPU is a genius, right? It's like a master chef who can handle incredibly complex tasks one after the other flawlessly. But your GPU, oh, your GPU is an army of line cooks. Each individual cook only does one very simple thing, but you have thousands of them doing their simple task all at the exact same time. And it just so happens that trying to guess a password is a whole lot of very simple tasks. Because people used to rely on CPUs, security audits were incredibly slow. Trying to check passwords one by one by one was, as one source put it, literally like watching paint dry. It was this tedious, serial process that could leave a company exposed for weeks. So, what was the real-world impact of switching from that one master chef to the entire army of line cooks? Well, the time it took to do a really thorough password audit went from taking weeks all the way down to just minutes. Now, that's not just a small improvement, that's a complete revolution. But believe it or not, the story doesn't even stop there. This new era of high-speed security testing is being fueled by a whole combination of powerful technologies all working together. The GPU really was just the beginning. First up, we've got AI accelerators. This is like giving your password cracking tool a PhD in human psychology. Instead of just brute forcing A, B, C, it learns from billions of passwords from past data breaches. It starts to spot patterns, making way more intelligent guesses about how we humans actually create and reuse our passwords. And next, you have the cloud. So instead of needing one super powerful machine in your office, imagine renting a virtual stadium full of computers for just an hour. This makes a staggering, almost unbelievable amount of power accessible to pretty much anyone, on demand. So the crucial point here, the big takeaway, is that the modern toolkit for a security pro isn't just one thing. It's this killer combination. You've got the raw parallel power of GPUs, the predictive smarts of AI, the nearly infinite scale of the cloud, and of course the sophisticated software like Hashcat that ties it all together. So why does all this speed, all this power actually matter in the real world? It's because in the cybersecurity arms race, speed has become one of the most critical strategic advantages you can have. I mean, think about every major data breach you've heard about in the news. They almost always reinforce the same hard lesson. Weak passwords are a catastrophic vulnerability. The ability for a company to find and fix those weak points before an attacker does, well, that can be the difference between a close call and a front-page disaster. But of course, this incredible power is a double-edged sword. The very same tools that help a company secure its systems can be used by attackers to cause immense harm. And that's why their use is and has to be governed by very strict legal frameworks and a strong code of ethics. This kind of power has to be used to protect, not to harm. In all of this, it leaves us with a really fascinating and, maybe a little unsettling question for the future. In a world where a complex 8-character password with symbols and numbers can be cracked in minutes, our entire idea of what makes a password strong has to change. It pushes us toward brand new ideas, things like passwordless logins and biometrics, and it forces us to constantly redefine what it really means to be secure online.